With that, I want to move on and introduce our keynote speaker, Deborah McGinnis. We are thrilled to have her here. Dr. Deborah McGinnis is a pioneer in computer science and in the semantic web. She's an expert and active contributor to the field of artificial intelligence, specifically in knowledge representation and reasoning, description logics, knowledge explanation, and trust. She's a leading authority on the semantic web and has been working in knowledge representation and reasoning environments for over 35 years. She received a Bachelor of Science in Math and Computer Science from Duke University and a master's degree in computer science from the University of California, Berkeley, and a PhD in computer science from Rutgers University. Currently, Dr. McGinnis is the Tetherless World Senior Constellation Chair and Professor of Computer and Cognitive Science, and also the founding director of the Web Science Research Center at Rensselaer Polytechnic Institute. Dr. McGinnis has been recognized with awards as Fellow for the American Association for the Advancement of Science and a recipient of the Robert Inglemore Award from the Association for the Advancement of Artificial Intelligence for her service and leadership in semantic web and AI research over the years. Her primary research thrusts include work on semantically enabled schema and data integration, ontologies, open linked data, data science, and foundational knowledge representation and reasoning to support a wide range of informatics and analytic efforts. Her smart data portals and semantic architectures currently support projects in exposure science, personalized health, material science, machine common sense, and many, many more areas. She's attended MCBK meetings in the past and has been an enthusiastic supporter of our efforts in our community. We look forward to her remarks and thoughts on mobilizing and moving CBK forward. So please welcome Deborah McGinnis, and thank you for joining us this morning.
Thank you. It's really just a pleasure to be here. I wish we could be here in person, and I look forward to the next time when we can be here in person. But in the meantime, I'm going to talk some about moving towards more computable knowledge. You know, it's not that we don't have computable knowledge today, but I'm going to talk about ways and examples that we're moving towards more computable knowledge. And what I'm going to try to do is also point out some places that I think we as a community could make a difference with increasing the impact of the insights that we can get from computable knowledge and the uptake we can get. So I'm going to basically have three themes. And these are three areas where either they're here today or emerging today, and they could have more impact if the world, but particularly this community, might focus on some areas to improve the uptake. So the first one is recommender systems and cognitive assistance. You know, they're clearly here today, and I think the world believes that they're going to be just increasing. But they could have improved impact with some enhanced explanation and usability. And in particular, in biomedical applications, that becomes even more important, where you're looking at many suggestions that might have big impact to life situations. Another one that's more in an emergent status is a personal health knowledge store or a personal health knowledge graph or a user-centered knowledge store. I think these are clearly emerging. But given that when we're healthy, we don't interact with the medical system all that often, but we interact with things like our phones and our Fitbits or other instrumentation and our environment. When we've got access to our own personal information, and when we can give that access to the right people at the right time without overwhelming them, without having medical doctors feel like their medical insurance is responsible if they haven't acted on reams of data, then these personal health knowledge stores can make more of a difference. And I'll give examples of both of these and some challenges that we ran across as we were addressing both of these. And this last one, I think, is more in the early emerging status for meta descriptions aimed at use and reuse of knowledge resources. And that encodes things like the embedded assumptions and the use cases that were used before some resource was built. And all of this is kind of aimed for building for longevity and reuse. For those of you who actually knew me before or listened to that wonderful introduction, You know that I've been working in ontologies and ontology-enabled environments for many decades, but a lot of those ontologies have been around the particular domain. And some of these ontologies and vocabularies have been around for decades and are really important and useful, but they often don't have information about what they were really built for, or what assumptions are really embedded in there, when you shouldn't use them, as well as when you should use them. And I think as we get more information like this out, even if it's just a de facto standard, but ultimately we want to get these meta descriptions going through standards efforts, we will see much more interoperability and more impact from our smart resources. So I'm going to give my examples largely in the setting of two projects. The first one here, HEALS, Health Empowerment by Analytics, Learning, and Semantics. It's an AI Horizons funded effort, joint between RPI and IBM. And the goal is to use artificial intelligence to basically help improve health, to relate behaviors to medical condition information, to produce personalized disease prevention as well as disease management insights that are aimed either at patients or their healthcare team or the clinicians. And potentially most importantly, or at least very importantly, have explainable data-driven recommendations. So on the left, you see a lot of knowledge graph information that might have largely been put together by mining, because if you're going to build these things at scale, you're going to have at least semi-automatic techniques for building the background knowledge stores. You might have information about known indicators for a disease condition or disease prevention. Ultimately, you want to have that knowledge graph appear to be locally consistent, locally available. So, might be on your phone or at least accessible through your phone. And then it would have access to online behavior information, your instrumentation, your health content, your surveys, et cetera. But of course, there's a lot to actually do that. And within this project, there's three current thrusts, two of which I'm going to talk about in this talk, and the third one I'll answer questions about if you bring them up. But the first one is personal health recommendations. And although we're trying to improve health overall, many of our examples have been in the setting of type 2 diabetes. And we're trying to empower diabetic patients to improve health behaviors by tailoring their health information and recommendations to their lifestyles and preferences, and understanding the context in which they sit. So it might be a pre-diabetic setting, but maybe the indicators of diabetes are going in the wrong direction, or you might have been already diagnosed with this. And so we would want to make recommendations that someone believes that the patient or the patient's care team is likely to act on. And often that means being able to give an explanation, and often that means being able to have the data behind that recommendation. And then the second thrust, semantics for health and clinical reasoning. And we want to enable a medically aware person to have greater trust in the clinical decision support for the system recommendations. We're aiming initially at clinically aware people because they've got a different set of background, but that also means that they might be able to have the information to provide to their patient or the patient care team. And the third main thrust in this project area is improving health equity using machine learning, fairness, and semantics. And I don't have slides prepared for that today, just from a timing perspective. So this kind of busy diagram is kind of a graphical display of how the HEALS, the Health Empowerment Using Analysis, Learning, and Semantics Personalized Diabetes Advisor works to combine personal health information, personal food diary information, our food knowledge graph that I'll have some slides on, some clinical practice guidelines, in this case from the American Diabetes Association, on food and lifestyle and recommendations, ultimately to support healthy lifestyles. So lots of these little blobs in the picture. I'll have a slide or two on. And this demo actually brings together a lot of the pieces of this larger project. Oh, in the larger project, we're in year 4 of a 5-year, $5 million joint effort. So it's got a pretty significant staff, and we've been doing it for a while, and with, I think, a lot of success, but also exposing a number of challenges. So coming in are some personal health records that typically come in, at least some portion of that in a structured form. And then we use our semantic data dictionary approach to get that ingested into our personal health knowledge graph. Also information coming in is a food log and a time series summarizer pulls out information from that and puts it into the personal health knowledge graph. A hybrid semantic reasoner that's got deductive as well as abductive as well as inductive. So a lot of different kind of reasoning components, works over that, uses information from clinical practice guidelines and dietary guidelines, and then also has information about user dietary needs and preferences. So it might be allergies, and it might just be, I don't like peppers, or I don't like something. And then a user comes in with questions and asks questions like, what should I eat today? Or what's a recipe that is compliant with my allergies, my conditions, and maybe the food in my refrigerator that I've told you about. And then it can give you some recipe recommendations. And when that question comes in, we do an expansion of the question using our background knowledge about what terminology you've used and what background terminology we have. And then we work through our knowledge-based question and answering system that works over a food knowledge graph. So there's a lot of components here that we kind of built ourselves, but also, you know, one of the things that I do as we all advance in our careers is we all try to stand on the shoulders of giants when we can. So we look for reuse of resources where it makes sense and where we can glue them together in smart and useful ways. So this diabetes advisor has information about the person interacting with it, you know, like their age and their weight and their disease conditions or lack of disease conditions, including their likes and dislikes. You might interact with it with knowing something about the dietary goals, knowing about how your carbohydrate intake has been in the past. This setting, the next slide, you'll see this person actually is on insulin. One of the clinical practice guideline recommendations is that you keep a consistent level of carbohydrates when you're on insulin. And so, you know, this person did okay, but not great at that. They might have specific questions that apply to make some recommendations, and they might get a recommendation, and then they might get information about why they got that recommendation. So, and also you get information about why this guideline applies to you. So you're on a fixed insulin dosing, so clinical practice guideline, and here's where it says it if you want to go look it up. And then actually, if you go look it up, you can even see the study or studies that the clinical practice guideline refers to on making that recommendation. And you might ask a question like, suggest a good lunch dish without meat. In this case. And so you might get these two, and then you get rationales for why you got them, and including things like there's a lower carb replacement for fish tacos in your history. So if you replace the taco shell with the lettuce wrap, you go down in the carbohydrates. So we're trying to not only give you recommendations, but help you trust the recommendations and provide some health literacy, improve the health literacy while we're providing those recommendations to improve the patient understanding. And also, if they want to dive into the details, we want to provide the ability to dive in to see where the information came from, why something applies to them, what the evidence is that it's contributing to a positive lifestyle change. And also, this is informed by interviews with dietitians, and the explanation pieces are also informed by interviews with relevant doctors. So what are some of the pieces that we needed to do to power this? One is build this food knowledge graph. So it's a semantics-driven knowledge graph aimed at supporting recommendations. And we want to have this single cohesive food knowledge graph. It might be built from a lot of different parts, but it appears as a single cohesive knowledge graph. And since we want to suggest some recipes, we need to be aware of nutritional content. We want to at least be connected to food vocabularies, and we want to reuse food vocabularies where it makes sense. And there's a number that exist. So we link to those existing ontologies and vocabularies. We're attempting to make it straightforward to use, modular, and make it reusable. We keep track of the provenance for every assertion. And, you know, one of the take-home messages that I hope people take away from this is don't make provenance a second-class citizen. Think about it when you're starting your project so that you don't have to try to shoehorn it in later, so that we can relay to people what we relied on and they can see, for example, who else trusted it or how recent it was. And this effort was aimed at use cases looking at personalized recommendations that include substitutions, suggested substitutions with information about why. So the primary content is a large recipe knowledge base that includes things like steps and sources, preparation time. So you can ask questions like, give me a recipe that takes less than 20 minutes, or what the serving sizes are. We want to have authoritative information about nutritional content. So our authoritative source was the USDA nutrient database. And the food, we heavily reuse the food ontology, which is a very broad ontology, and it's, quote, field to fork. So it includes information like the processes used in growing, treatment processing, packaging, et cetera. And throughout the talk, I've got a lot of links. Like this is a web page, a GitHub web page that points to our resource paper at the International Semantic Web Conference, that points to the resources used in it, that provides the use cases, that gives a little demo scenario, et cetera. So how did we actually do that? We've got some structured content coming in, and here's a tiny little example from the USDA data. And then we want to get that into our structured content. So all of the columns, IDs are in here, and the attributes are linked to things. So they're linked, for example, this first one is linked to a KEBI term, Chemical Entities of Biological Interest Ontology. It's also linked to DBR, so the letters in front of the colon are the ontology that the information is coming from. So it's also linked to the DBpedia resource ontology. So all of these terms get mapped to an ontology that we're reusing. And then we also keep track of the units, and those things are mapped. And then we have the label. And in some projects, we do this by hand when we need to do it very precisely. In this project, the scale required us to use some semi-automated techniques. So we used OntoFox to make recommendations for the mapping. And we also used our semantic data dictionary approach that basically goes from data dictionaries and code books, linking semantically to background ontologies so that we can leverage the information in the ontology to get to the implicit information that's explicitly stated in our resource. And a paper on the semantic web or semantic data dictionary methodology is linked there as well. And then going a little bit further, we developed this food explanation ontology, which was aimed to explain our food recommendations more thoroughly. So it leverages an explanation ontology that we built for we informed it from interviews with doctors, since we were working in a diabetes setting and we were trying to explain recommendations around diabetes. We interviewed a number of endocrinologists about the types of questions that they would want to see asked and the types of answers that they would want to see coming back. And so we categorized a number of types of explanations from that, put that into the explanation ontology, and there's a link to the explanation ontology and seeing demos of it in use. And then also another ontology that actually came out of an ontology engineering class that I and Elisa Kendall taught on what to make. So the motivating use case is I've got these foods in my house or in my refrigerator. I've got people with the following food preferences or food allergies. What should I make? And so we had some background ontologies there. And then we focused on 3 types of explanations. Contextually aware explanation. So given this context, how should I answer? Contrastive, why X versus Y, and counterfactual, well, why didn't something happen? So there's a black box recommender system that makes a recommendation. It uses the food explanation ontology as well as some background information to provide the explanation. And the types of questions might be what non-food specific factors contributed to this recommendation. And so, maybe I ate 5 donuts for breakfast, so my carb intake was through the roof, although that actually is a food-specific recommendation. But maybe I'm going running later today, so I can have a higher calorie input here. Or why should I eat one soup over a different soup? And what if I was pregnant? Would I still get sushi recommended to me? Oh, so behind the scenes in that project and in the broader project, there's actually, not surprisingly, the knowledge graph and the ontology is kind of in the middle of everything, but they're pretty hidden. And they're formed from the literature, from databases, from public data sets, from linked open data. So it might be authoritative literature. Sometimes you've got some grayer literature, but that still is useful in some settings. We get that information in using semantic extract, transform, and load and the semantic data dictionary, using natural language processing techniques and machine reading techniques. So, all of these come with, not always 100% precision, which is one reason why provenance about how we got the information is very important to have in there. The user interacts with a semantically aware system and with the cognitive agents that use a lot of different kinds of question answering portions. So there are statistical reasoners, deductive reasoners, abductive reasoners, machine learning components, and ultimately you interact with this and hopefully you don't really see the guts of this and you get an answer that's context aware and providing provenance if you want to dig into something. But there's challenges. And actually, anybody who's worked in these large semantically consistent or semantically aware systems knows about the challenges of different levels of abstraction, things built for different purposes that might be a mismatch. The left side of this slide actually is from the Food On website, and it says, "What's in an egg?" And when I think about an egg in a recipe, I, like probably most of you, think about a chicken egg, or more precisely, according to them, a whole egg from a hen, adult female chicken, as a food product. But, that's what we usually think about. But, like I eat caviar, so I do eat fish eggs, but, that's not the primary thing I think of in recipes. And that's not the primary thing that recipes are referring to. So where do I map into this? And do I bring in the whole ontology, or do I bring in a piece of it? Or do I try to work with an abstraction of it? And this problem we'll see all over the place. It's just exemplified here. And then you also have a lot of different kinds of vocabulary. So for example, in recipes, you might see a pinch of salt or a pat of butter, which somebody's going to have to translate into how big that is. And so there might be common vernacular or more medically specific terminology or something that's aimed at a different level. And that, of course, creates some of the many challenges that we get when we're working with these systems. These days, and actually I guess probably for the last 20 years, I've really been a giant proponent of use cases. They help you scope, they help you prioritize. And although I feel like I'm a pretty flexible team member in these large, diverse efforts, I don't think I ever give up on getting use cases before I start projects, because I don't know a better tool for scoping and prioritizing. So this is a template. We call it the Ontology Engineering use case template because we teach it in the Ontology Engineering class, and we've got examples of use cases filled out and the template for reuse, but it's been informed by a lot of different communities. So NIST has used it, and we've used some of their content. ESIP, or System Information Partners, has used it. A lot of different application areas have used it, and in both academic and business settings. And some of the most important components of it, so you always want to say what you're doing, give some kind of usage scenario, some kind of flow of events, what resources you hope to use to get the answers. But one of the things that a lot of people leave out that's incredibly important is competency questions. So what questions do you need to be able to answer? And what are some example answers? And how did you get those answers? And what was hard about getting those answers? Because really, if there's a database that exists that you can just do a SQL query to get the answers, well, don't build a whole new application. But so we need to understand those pain points. But please build use cases, and also please publish the use cases, because they provide some great metadata about why some resource was built. So we use this kind of methodology that starts with the use cases, figures out, what vocabularies and starting points we've got. There's a lot of different resources like data dictionaries and code books. They provide some terminology. Expert interviews, sometimes that's a narrative. There's foundational ontologies that often you want to inherit from. You want to get your generated ontology that, even though I live to build ontologies and I love ontologies, but these days, I really build ontologies that are glued together pieces of other ontologies that are reusing other people's work, and that I develop a methodology for how I'm going to stay up to date and consistent with, so that I can put it in a framework and have some kind of knowledge enhanced search. And the two frameworks that are behind the applications that are in this talk are the Human Aware Data Acquisition Framework and the WIAS Knowledge Graph Infrastructure. So now I'm going to talk a little bit about some user-centered context and knowledge-enabled explanations. And this is kind of the health explainable AI persona continuum from some kind of medically or clinically aware person, from the data scientist to the clinical researcher to the clinician. And this is where we're targeting our explanations initially. And they come in with different background knowledge, and they have different types of focus areas that they want to get their explanations about. And so in this work, we look at our different explanation types, and this comes from the results of the surveys with the doctors on the types of explanations they wanted to see. And there's links to papers where we talk more about it. And looking at the different types of question types, then how do we actually get that, that explanation out? So in this case, we're looking at, sorry, I'm blowing this up so I can read it better on my screen. We're looking at explaining a risk in a comorbid condition of diabetes. And so you can look at the prediction components, the main aspects that influenced a prediction, the provenance of the information, the linking to the ontology term, so you can see what ontology term it's connected to, and then you get the explanation that has components of the context and the influencers for the machine learning recommendations, as well as the provenance for that. And there's a poster on this at this conference that I'll provide a link to on the last slide. So the approach is context aware, using multiple methods, trying to make actionable and patient-specific domain knowledge aware answers. And we're going initially from a pre-canned set of clinically relevant questions that were informed by the interviews with the doctors. So we've got the risk prediction models, the post hoc explainer, Of course, we use natural language methodologies, and then we utilize our background ontologies, our clinical practice guidelines, and the patient data to give explanations that are contextualized by the patient and the patient's comorbidity risk, and then presented in a dashboard that's friendly to the user. And here we're initially aiming at clinicians, so to a clinician-friendly dashboard, but if you're aiming at patients, then to a patient-friendly dashboard. So the next theme, so that's in the area that's here today. But even with the here today, there's lots of challenges around, I think, the explanation and usability. And the next two I'll talk about more briefly, and they're more emerging. So these user-centered knowledge graphs for health should appear to have you in the middle, that no information that goes beyond your health record, like your activities and what you ate and your step count. And then actually make that available in a personal health setting. So I and some colleagues have run 2 rounds of the Personal Health Knowledge Graph workshop this one was at the Knowledge Graph Conference this year, and we also did the last one at the Knowledge Graph Conference last year. And I believe, and I think the world believes, that the future is going to encompass some kind of personal health knowledge store that's accessible at the right time, at the right place, pieces of which are available to your healthcare providers. But we need solutions around access control, storage. I want to have some of it probably on my phone, or at least accessible to my phone, but it's so big that I'm not going to have all of it on my phone. So it needs to be accessible in the cloud or whatever, but we need to have modeling that supports just-in-time, context-aware content in ways that can be given to the medical professional in ways that they can accept it and not be overwhelmed by it, and in ways that the patient or the healthcare team can use it. The last area that I'm going to talk about is set in a different project in the National Institute of Environmental Health Science funded Human Health Exposure Analysis Repository. And this is an image of the data center, the HERE data center. I run the data science core, which means I'm in charge of the ontology and the ontology enabled resource that supports the statistical services where they're getting the data, and the data repository management where they're maintaining it. And we're trying to provide access to exposure and health outcome data to enable construction of customized harmonizable data sets. So here it's really important that we've got more precise mappings, because if you're going to do significant statistical analysis, you better understand what data you actually put together and whether it was put together in a reasonable way. So we facilitate that harmonization and support the pooling of the data for analysis. So ultimately, we want to get this study content into the knowledge graphs. So the study content comes in, goes into a knowledge graph, and then you can do faceted search or generate customized data sets on demand. And so there's a lot of challenges with this, of course, even though we get data dictionaries that do have column headers and they do have code books, they often don't provide enough metadata. There's quite a lot of variability in the terminology. There's information that's missing. There's mismatches even in what you think might have pretty standard vocabularies. So these are from 3 different studies for education level. And actually, you can see more about it in these 2 papers for how the mapping was actually done. And then it needs to get mapped to a big background terminology that we've built. So this started as the Child Health Exposure Analysis Repository Project. And now the follow-on project was the Human Health Exposure Analysis Repository Project. And the ontology pulls in a lot of background ontologies, things like semantic science integrated ontology that already integrates a lot of science-aware ontologies. the World Wide Web Consortium's recommendations for provenance on the web, Unit's ontology. And these we actually import, but then there's a lot of big ontologies that we reuse, but we only reuse pieces of them. So we only use minimum information to reference an external ontology term from things like KEBI, chemicals of biological interest, and Uberon for ontology or for anatomy. And there's the good news and the bad news is there's a lot of ontologies to choose from. So we've got this kind of large spreadsheet that makes recommendations for when to use an ontology when you're looking for mapping a term. We also have some learning techniques that suggest a mapping if a term is not already mapped. But ultimately, we've got to get this data dictionary like BMI or gestational age at birth mapped into these entities in our knowledge graph. And we do that using this semantic data dictionary that right now epidemiologists fill out, but we have tools that suggest a way to fill it out, to connect the terms to who it's about, to what the implicit object is that's in there, so that we can create this data center portal that shows the number of studies that are in there, that gives some distribution about the content that's in there. And that allows you to do searches for things like, get me studies that have information about childbirth weight, gender, gestational age, some information about the mother, that where there were exposures to some particular metals. And that might provide a number of studies, and I can search by the study, I can select by the study feature, and I can see in this that this is mostly information that's color-coded. So I've got mostly information about the children, but I also have information about like the third trimester data, et cetera. And then I can get that harmonized data and I can dump it out to a harmonized data set where we could potentially do pooling. So my take-home message is kind of what I started with, that there's at least these three themes that are here and emerging today. Cognitive assistants, I think, are here to stay, but we could see more impact and benefit if we can enhance the explainability and usability. And I think we've made some progress there, but I think the world could make some more progress there. I think these user-centered knowledge stores, our personal health knowledge graphs, are emerging. And the world needs to do some more work on access control and interoperability. And then maybe the most operational message for this community, especially given one of the breakout groups later in this conference, is that meta descriptions for resources, so descriptions about what the resource is, how it might be reused, how you might interoperate with it, when you might skip interoperating with it. I think those are part of the future, and they are really going to help interoperability, and they're already starting to help. But I think we as a community could spend some more time there. So with that, and then there's two posters that I provided links to, poster 4 and 15 in this meeting, and there were many people contributed to this talk. So I've got too many names to mention. And then some links to the projects that I mentioned, Heels in Here, and the knowledge graph infrastructures that I mentioned. And with that, I'll take questions.
Terrific. Thank you so much. What a wonderful talk and what great vision you've given us for the potential here. We have just a few minutes for questions. And before we break into that, I'll tell people we will post your slides. You will be able to follow these links, see the papers. You can certainly go see the poster as well. And we'll try and follow up on any questions that we don't get to in this session because there really were so many. But let me go ahead and start with Blackford Middleton's question on how one validates a personal health knowledge graph. How is it maintained? What are the sources of validated clinical knowledge or real-world evidence for the K-graph? And then I'll just tag on, what in terms of regulation or standardization, what opportunities or challenges do you see there?
What a spectacular question. And clearly Blackford should be a keynote speaker at the next knowledge graph, personal knowledge graph workshop. Because this, he just asked a ton, or you collectively asked a ton of excellent questions. So, there's no perfect answer to this. But for all of our projects, we always suggest some kind of regression testing. So for information that we put in, we try to have a regression test suite. But of course, that's kind of an anecdotal way of doing this effort. But at least make sure that when you add more information, you're not breaking things that you knew how to validate in the past. I don't think you're ever going to get a perfect kind of validation here, but when you've got questions and answers, you can see whether you're getting the right answers out of that, especially when you're doing some kind of automated extraction. This is going to be a challenge. We've got methodologies where we go out to people that we've deemed as experts, whether they're clinicians or whether, like they helped put together the clinical practice guidelines. We're working with people who are doing systematic reviews and trying to follow those methodologies. Actually, we've got a proposal pending to NIH to do a systematic review over these kind of resources so that we can say at least these are the ways that we have validated, so that you can say that, at least it doesn't have these kind of problems, or at least if you want to ask a question about that clinical practice guideline, at least this is the version, this person or this entity validated it. And, maybe we're validated against the previous version instead of the current version. So let's see. There's methodologies that we're trying to follow. There's regression testing that we're trying to follow. There's checking against the competency questions that we're trying to follow. What piece of the question did I not answer yet?
I think you've got a lot. The regulation, and actually, let me just sort of jump in. And what role do you see for our trust and policy working group and priorities you might suggest if there are gaps that we might be able to contribute to?
Well, I think these kinds of validation, transparency about the validation, the methodology for building and the validation process, I think that's kind of the holy grail for really being accepted into particularly biomedical settings or any kind of critical setting where, life is at risk or, very important. It's one thing if I'm recommending what kind of present to get for somebody's birthday about, what kind of sweater. But it's another thing if I'm recommending changes to medication or even just diet that could hurt you. So, yeah, I think actually if we can set up benchmark tests, this is one of the themes that's true in the ontology world. Things like LUBM, like one of my friends, the Lehigh University benchmark said, he's made a career out of creating these benchmarks that things are being run against, or at least processes by which we could do some testing. I think this would be very fruitful for that working group, and I'd be happy to participate in those discussions.
Terrific. Thank you so much. I want to try and squeeze in two more questions before we move on. And there's been so many, so we'll follow up afterwards with folks. Terry Wheeler asked a very interesting related question about your work in the populations that you included, the participants. Did it include a clinical trial, and did you recruit equitably from minority populations and considerations of culture on their diets?
Yeah, really good question. So one of the things that we did was we just looked at the literature or the studies that were used in the clinical practice guidelines, and then we looked at the studies that were referenced, and then we looked at the table ones, or the description of the study population that was in that study, and then we made a vocabulary, the study cohort ontology, to describe who was actually studied, so we could expose who actually got studied. That's different from the recruiting, but in a separate effort. In the piece that I actually didn't have slides for, my colleague Kristen Bennett and her student Meow are working to suggest ways to create a a study population that wouldn't be biased, given particular properties that you're looking for, given age and whatever properties you want to be not biased for, how to suggest recruiting against that, against a baseline population. And often a baseline population is from NIEHS, but somehow you get a baseline population and then you suggest ways to recruit equitably and fairly. Right now, my work really exposes it rather than goes the next step to recruit.
Terrific. Thanks. And I'll take this opportunity to plug our sustainability working group, which Terry Wheeler co-chairs, and a lot of these topics come up in that context. One last question from Ganesh Kuru related to use cases. And someone else had asked, where can they publish use cases? So first of all, where would you recommend we publish them? And Ganesh asked, what would your recommendations be about how we should learn from use cases to refine and improve metadata standards?
Ooh, really good questions. And actually, we probably should start something like BioPortal for use cases. I mean, today I would publish wherever I publish my ontology and wherever I publish my application, I would make sure that I have my use cases. So I publish in kind of all the standard ontology portals, and then I would have my use cases there as well. And, these days, we do a lot on GitHub. So a lot of our source code is on GitHub, our web pages, I guess 3 or 4 of the links probably that I've got in this talk are on GitHub. And so the use cases are hanging off of the GitHub resources as well. But if I were looking today for one resource to go out and find a bunch of good use cases, I think I would have to do a lot of searches. And that second portion of the question, I now, actually, as I was doing this talk, I was thinking I'm going to add another category to my use case template for when to and when not to use a resource that was built to address this use case. Because actually the structured components in our use case template, I think, are a candidate for a starting point for a metadata vocabulary. So that we could look at least get some structure about, the type of user and the type of resources.
Terrific. Thank you. And Guinness is active in our standards and technical infrastructure working group, which is exploring some of these metadata issues. So this was just wonderful talk. Deborah, I can't thank you enough for joining us this morning. You have really tapped into so many areas that we want to explore more deeply in MCBK and have really motivated us and given us a charge for the next 2 days. So thank you so much for joining us, and we look forward to working with you to answer these and many more questions in the future. So I hope you can enjoy the rest of the conference. And again, thank you so much for joining us.
Yes, I will stay tuned and I will try to answer follow-up questions.
Wonderful, wonderful. Thanks so much.